Good morning, everybody. I would like to extend a warm welcome to the Tech Talk session, which is being conducted by SolutionBuggy. I hope I am audible to all of you. So today we'll be having a look at two main topics. The first one being biogas and bio-CNG, where we broadly talk about the market opportunities, current demand, production process, complete knowledge on the waste to energy program, a little bit of what the government subsidies and grants are, and what are the investments and the ROI that you can look at. The second session for the day is on ethanol. Um, and like as usual, on most of the webinars that we've been conducting, especially regarding ethanol and also the bioenergy related webinars, we have about 600 plus registrations today for this tech talk, and we expect 200 plus participants for this session. Before I start, a quick introduction to SolutionBuggy, who we are. We are an online platform to connect the manufacturing industries with the experts. We can proudly say that we are India's largest platform for the MSME sector in the manufacturing domain. We have about 10,000 experts on the platform. We have completed about 2,300 projects across India, as well as in the Middle East over the last 6 years. And when I say projects, it could be anything from a one-day consulting assignment, say for example, a lean management training or a training program, and all the way up till setting up of industries from concept to commercialization stage, which could stretch for more than a year. So what we do, it includes basic market research, product identification, detailed project report, machinery procurement, plant setup, commissioning, supply chain management, sales and marketing, and host of other things that is typically involved in a manufacturing industry. I am Guru Prasad Bangle, director at SolutionBuggy, and have about 20 plus years of experience in consulting. And like I said, the reason for this webinar is basically to share the program and the new policy that has come up in the biogas and bio-CNG, and the aspects that have been included in the new circular for waste to energy policy, which has been released in November 2022 by the MNRE, that is the Ministry of New and Renewable Energy. With that, I would like to introduce our two speakers for the session today. Mr. Arvind Kumar, he has about 40 plus years of experience in the field of renewable energy, covering rural and urban areas in domestic, commercial, and the industrial sectors in the state of Uttar Pradesh. He's also having a master's in rural development, and he's an MNRE empaneled monitoring consultant as well as a chartered engineer. Prior to this stint at Renewable Energy Department, he has also been a scientist at BARC Mumbai. We welcome you, Mr. Arvind.
Thank you.
Next, I have Ms. Medha Gujarati. She's been associated with SolutionBuggy for quite some time. She's a veteran here. She's the founder of Catalyst Capital Advisory, has more than 17 years of experience in subsidy consulting and industrial project management. She has been instrumental in getting subsidies and grants for 100 plus projects. Prior to this, she has worked in investment banking divisions of Bajaj Capital, Knight Frank, and she's also been instrumental in getting sanctions for infrastructure projects like mega food parks, cold chains, textile parks, logistics parks, etc. She's a PG in business management and has done her certification in private equity and VC from SDA Bocconi, Italy. She's also a visiting faculty in REMI, Mumbai. I welcome you, Ms. Medha.
Thank you so much, Guru. And good morning, all.
So, I'll give me a second and I'll just share my presentation. hope my screen is visible. Just to give you an understanding of today's flow, I'll be giving a quick introduction on what biogas involves and what bio-CNG production involves. And then I'll hand it over to Mr. Arvind, who will be taking us through the technical aspects of both the biogas and bio-CNG production. And then Ms. Meda will be talking about the various schemes and the change in the current scheme for which has been proposed by the MNRE. Basically, like all of us know, biogas in its crudest form involves the renewable fuel that is produced by breaking down the organic sources of waste. And when we say waste, it could be anything, the 5 kinds of waste that have been shown over here. And it could be, there are different processes in which it is made. And the subsidy that the government is giving is for both the gas that is being produced and also the electricity that is being produced from the biogas. So when we look at the market, if you see, especially in the rural sector, biogas production has been there for quite some time. But over the last 3 years, when the new policy from the waste to energy policy has been introduced, there is a phenomenal change in the production economics and also the government's buyback that is being given. So if you look at it, the market has suddenly boomed, and although it shows about 1.4 billion in 2021, we expect it to double almost by 2029, and this is at a very conservative estimate. So what are the uses of this biogas is basically, like I said, into making the gas as such, which could then be converted into electricity, or it could be refined to get into vehicle fuel or heating requirements in industrial as well as residential purposes. One big new requirement that has been added in the new policy is also the industrial gas requirement. These are typically the biogas plants that you could have seen in the rural as well as in the tier 2 and tier 3 cities, especially, which is very common. And how do we actually use this process? Of course, Mr. Arvind will take us through a detailed explanation of this, but just to give a bird's eye view of how the process works. So basically, all the waste, that is the crop waste, agri waste, or the food waste, and the major source in India being the cow dung, which is converted into, is used in the anaerobic digester, converted into a biogas, and which in turn can be converted into electricity or heat as is required. Within biogas, when it is converted into biomethane, then it is classified as bio-CNG, which can be used as fuels for either industrial purpose or as for the automotive requirements. Other byproducts which we could look at are also fertilizers or soil enhancers, etc. Next topic which we'll be covering for the day will be bio-CNG. Like I said, bio-CNG is basically biogas which has been a more concentrated form of methane which is there in it, which has more than 90% concentration, and again it is derived from the same processes, that is using the waste to energy. So what is different in a bio-CNG is basically, apart from the normal biogas production facility, you will have equipment such as the hydrogen sulfide scrubber, the dryer, filtration system, a gas compressor, and the storage norms which are different for bio-CNG, because it has to be basically bottled and sent to the bio-CNG stations. As of today, the price for bio-CNG from the government is fixed at 46 rupees. So where are the business cases is it's humongous. Obviously, there is a huge I would say, problem that the municipalities are facing with the waste that is being generated, both the commercial as well as the residential waste, especially in the metro cities. So this is where this waste to energy policy comes in place, and tries to incentivize anybody who is getting into manufacture of biogas and bio CNG. So, and when we look at the scale of plants, of course, Mr. Arvind will also give you a detailed kind of investment and ROI calculation. But this is just to give an understanding of what kind of plant can anybody look at. The plant sizes, like as is mentioned here, can vary from small to large, with an investment potential of anything between 50 lakhs to all the way up till 15 crores. And again, the subsidy is also classified based on the kind of investments that you're looking at. Ms. Medha will talk a little bit more on the various subsidy schemes that are available. It's not all rosy and all hunky dory. There is obviously there is the issue with getting regular supply of waste. Again, you will have to look at skilled manpower to operate these plants, which may or may not be available easily. Again, there is an issue with the supply chain as well, because you will have to be in close proximity to the bio CNG stations in case you are making CNG, bio CNG as your end product, because you'll have to supply it to those bio CNG stations. And then the long term visibility also has to be taken into consideration, considering that your raw material supply is going to be available on a day-to-day basis, because being a plant that has to run at least 300 days a year to be economically viable, you should be very sure on these factors. So these are some of the I would say the cons of getting into this industry. But obviously, over the next 1 hour or so, we will give you more in-depth understanding, and then we have a more rigorous consulting assignment that we can take up and see the feasibility of each of these individual plants. So, like I said, there is a huge impetus and huge, government, backing as well for setting up of these plants. In fact, at SolutionBuggy itself, we have about 4 new inquiries for setting up these plants, and we definitely see that this is going to double up over the next few months. And there is there is not just the government involvement, but also some of the existing petrochemical and petroleum industries who are, every day, getting, I would say, they're going to better up their policies. Even if you see today, IOCL or HPCL has the e-tender on their website for their, bio CNG requirements. And although this got a huge push when the waste to energy program came in, and then the impetus came down. But after this new circular that has come in November, we do expect a huge boost in the number of people, as well as from the government side, to set up these plants. With that, I would like to end my session, and I would like to now hand it over to Mr. Arvind, who will take us to the technical details of bio-CNG and biogas. Over to you, Mr. Arvind.
Thank you, Mr. Guru Prashad. And good morning to everyone connected with this. Now I start my presentation. This is, yes. Hello. Next, please. Hello. Yes. Now, as Mr. Guru Prashad explained already, that biogas is a mixture of gases. Am I audible to everyone?
Yes, sir. You're audible.
Okay. Now, the biogas is basically methane, and it has some water, carbon dioxide, and hydrogen sulfide. I will explain in the next slide. this is a fuel which is a future fuel. And please come back to the previous slide. Yes. Now, the important thing with the biogas is that this is a carbon neutral fuel. That means that whatever the carbon it has absorbed from the environment, it gives the same carbon back to the environment. So the net carbon transmission is zero. And that makes it very important because all other fossil fuels, they are giving carbon dioxide to the atmosphere. Then the important thing is organic fertilizer it gives. The organic fertilizer is, as you all know, that organic um farming is becoming important nowadays, and this provides a very good organic fertilizer to the fields. Rather, if you say, you must have heard about farmyard manure. Farmyard manure is a general cattle dung based manure, and it is a better organic fertilizer than the farmyard manure. And since its properties are more or less similar to the natural gas, as Mr. Guru Prasad explained, that it is going to replace the CNG in many applications. The second thing which I am going to touch is the use of biomass. Biomass is available plenty in our country, and the northern side, that is parali which people burn in the farms. This can be used very well in the for the power, for getting the power, and it can also be briquetted as a fuel. Next, please. Next slide. Next slide, please. Am I audible? You're right. As I explained earlier, and Mr. Guru Prasad also explained, that the main components are methane and carbon dioxide, which are obtained by the bacterial decomposition of the organic waste. Now, everything, any organic material which is subject to the bacterial attack, I should say it is a bacterial attack on them, any organic waste. Methane is the end product. You will always find methane in the end. Meanwhile, it goes through different processes of hydrolysis and acidolysis and is called anaerobic digestion. That is, anaerobic digestion means that the absence of oxygen. That is, the anaerobic bacteria eats away the organic waste material, and finally they provide methane and carbon dioxide in the system. But oxygen is not present with the anaerobic digestion. And then the bacteria is either inculcated in that system or is naturally grown in the system. They are very useful in the past also, and Indian government, as Mr. Guru Prasad said, that different type of biogas plants are using this anaerobic digestion, where it started in India, small plants, medium-sized plants, and now the focus is on large-sized biogas plants with the compression of the biogas. Next, please. I am giving you the composition of the biogas. Mainly methane is in the range of 50% to 70%. Carbon dioxide is in the range of 25 to 40%. Moisture is less than 10%. Hydrogen sulfide is less than 3%, and nitrogen is present at 1%. Next, please. Now, biogas, as I said earlier, and Mr. Guru Prasad also, that it has very properties very similar to the natural gas, and it is can be used as an alternative. Natural gas is or PNG. They are very common nowadays, being used everywhere, and this I have generally written that when CNG can be used, the biogas can also be used for water and space heating, drying, absorption, all those things, steam and electricity production, and in the vehicle also, in the transportation. Next, please. This I am comparing the compressed biogas with the CNG. Both are given highest specifications. CNG is 15958, whereas compressed biogas is 16087. And you will, when going through the table, you will see that methane in both the cases is minimum 90%. And CNG has many other components, ethane and higher hydrocarbons, then unsaturated hydrocarbons, carbon dioxide, sulfur, and moisture. Whereas uh, in compressed biogas, we do not have the higher hydrocarbons and unsaturated hydrocarbons. And it is good because the higher hydrocarbons and unsaturated hydrocarbons on combustion, they will provide more carbon dioxide to the atmosphere, which in that way, CBG is better than CNG. It is not having any extra hydrocarbons. Carbon dioxide is, of course, yes, it is maximum 4% is specified in the CBG, whereas CNG has 3.5% and sulfur. Next, please. This is the technology. I have tried to explain the basic technologies for having a bio CNG system. The first step, whatever the agriculture waste you take, if you are taking the paddy straw for this, then you require the cleaning and chopping of the waste. But if you are taking breast meat and cattle dung, chicken litter, then you don't have this step. You can have just a crusher and feed it to the digesters. Just digesters are a type of continuous stir tank reactors, CSTR they are known as, they are normally used in the production of bio-CNG in India. Other type is used is a plug flow reactor type, which is a continuous system again, and batch type. Batch type means it just have a big shed. You stack it with the paddy straw and add some water to it. Then give a retention period of 45 days. You will get the biogas.
Sanji, can you talk a little bit louder? Voice is a little feeble.
Oh, sorry. I will do that.
No problem.
I thought that I am audible to everyone.
You were audible, a little bit feeble it became. Now it is better.
Okay. I was explaining that the waste material is fed for anaerobic digestion to a continuous stir tank reactors. Stir tank reactors are designed such that we have a slurry of waste material which is continuously stirred. In old biogas plants, this stirring was not there. Because of that, some scum was found on the surface, which used to prohibit the generation of methane gas. But this is for the large biogas plants, these continuous stir tank reactors are used. The other type is used is the plug flow type, which is again a continuous reactor. And the third one is a batch type. Batch type means that you stack all the agriculture waste material like paddy straw and feed some water to it so that and seal it. After the retention period of 45 days, you start getting the biogas. But for very large plants, this is not used. In India, normally continuous stir tank reactors, known as CSTR, they are used. The second step after getting the biogas from the digesters is, as I showed earlier, it contains carbon dioxide and hydrogen sulfide. They are to be removed for any use of biogas because hydrogen sulfide and carbon dioxide both when compressed directly, they will start, I should say, corrode the compressor and the pipeline, everything. So they are to be removed. For this, there are three types of systems. One is a water scrubbing system. Water scrubbing system removes hydrogen sulfide and carbon dioxide. In Europe, monoethylamine is used, which is very efficient. And in large size biogas plants in India also, pressure swing adsorption system is used. There is one main point here that if you use pressure swing adsorption system, then we have to first desulfurize, that is, first remove the hydrogen sulfide from the system, from the biogas, and then we have to remove moisture from the biogas. Then only we can send it for removal of carbon dioxide in pressure swing adsorption system, where it is removed at a higher pressure and it adsorbs on the surface like charcoal, zeolites, and then we regenerate the adsorption material by changing the pressure. That's why it is known as pressure swing adsorption system. Monoethylamine technology is basically an absorbing technology. It removes hydrogen sulfide and carbon dioxide both. And biogas, which is obtained after this technology, is of very high quality. It is around 99%. Whereas normally in our water scrubbing system or pressure swing system, the biogas obtained is of 90%, slightly more than 90% purity. And the last step is that either this gas, just a second. Gas is filled into the cylinders or fed to the 100% gas engines. This is a schematic of compression of, rather of making of biogas. Here, as I said, that we require feedstock treatment before sending it to the anaerobic digesters. Two anaerobic digesters here are used. Since the retention period is 45 days, so we have to manage with two or more digesters. The bottom of the top gives the biogas, which is sent to the biogas storage vessel and then for further cleaning. The bottom solid portion is called digestate, which goes to a solid separator. That is, the liquids are removed from there and used as a fertilizer. That liquid is also recycled after cleaning and sent to the equalization tank, where it is used for adjusting the feed. The anaerobic digesters, the important thing here is that you have to maintain a pH value. The pH should not be very high in the anaerobic digesters. Otherwise, digestion will not take place. Next, please. Up to this point, there were general details about the biogas plant. Now, when we have to set up a biogas plant, the most important thing is the availability of the feed material, their types, quantity, and frequency at the location suggested for the biogas plant. Because the feed material, being agriculture waste, is not available all the time. It has a certain frequency in a year, and you have to store it for the period where it is not available. I am talking of the paddy straw. Second thing is, if you can use press mud and cattle dung. These may be available around the year. Press mud from the sugar mills, they are available at their factory sites. And cattle dung you have to get from a dairy. Now, cattle dung is available around the year. And press mud is also a mixture of cattle dung and press mud is normally used. Then the land cost. The project definitely, as an entrepreneur, you will see that the land cost is not high. So that it will definitely affect the viability of the project. Infrastructure available at the location, just like roads, electricity, these things must be available, because to start any project, you will require these things. Then comes to the designing of the plant. Feed material type. What feed material you are selecting, it will decide the main plant design parameters and its auxiliary equipment, what are they required. As I showed earlier that if we use paddy straw, then we have to chop it and clean it and equalize it. So, but for press mud and cattle dung, we can directly use it for feeding to the digester. So it will decide this project setting up, and later on techno-economic feasibility, financial analysis and project cost estimates are to be carried out with risk analysis. Risk analysis I have added here. We have to have a sensitivity analysis about the availability of the feed material. One more point is here that if you are buying the feed material from the other sources, then initially you will get it at a lower cost. But as the project picks up and say after a year or so or 2 years, the cost of the feed material is going to change definitely. Whereas the government has, Mr. Guru Prasad said that bio-CNG prices is fixed at 46 rupees plus taxes. They are fixed for now. But the cost of the feedstock and is going to increase over the period. So a sensitivity analysis is to be carried out. And then the government regulations like environmental impact and the socio-economic impact, they are to be worked out. Next, please. This is a general estimate for setting up a biogas plant or bio-CNG plant. Biogas for a biogas plant of 12,000 cubic meter per day capacity cost comes in the range of 6 to 7 crores. Bio-CNG is 20 to 25 for 4,800 kg per day. This is basically, they are based on, actually the figures is taken 12,000 cubic meter per day is for the MNRE subsidy basis. MNRE has for biogas, they have 12,000 cubic meter per day capacity, and for bio-CNG they have 4,800 kg per day. So according to that, the prices are taken. Similarly, the power plants based on biogas, that is the CNG which we produce is fed to the biogas engines, and or rather 100% gas engines for producing electricity. The cost will come to around 10 to 11 crores, but this cost is coming down. Maybe 6 to 7 crores per megawatt. It can come down. Next. This is an example I have taken.
Yeah, one more thing I would like to add here is, as Mr. Arvind said, the cost has been calculated, considering the subsidies that are available with the MNRE for a minimum viable plant. But it does not mean that smaller plants cannot be set up, and there are other schemes which can be looked at for setting up the smaller units. So, which obviously, when Ms. Medha will walk you through the subsidies, she can also give some highlights. Please proceed.
Okay, thank you, Gopal. This is a large size plant which I am showing here. It is 20 tons per day is the capacity. And normal plant can be set up in 10 to 12 acres, whereas you have to have feed stock for area is 35 to 40 acres. Annual now feed stock requirement is 85,000 tons of the paddy straw. That means the plant is to be located in an area where the paddy straw is sufficiently available. Second, it has a mixture of pressed mud and cow dung. So both these things, pressed mud means it has to be somewhere near a sugar mill so that your transportation cost is not high. And cattle dung is 3,500, means it has to be somewhere near some dairies or some cities where the cattle dung is in surplus, it is available. And the capex is around, for this size of the plant, is around 100 crores. And maximum admissible subsidy that I have worked out will be 10 crores, and IRR will be somewhere in the range of 12%. So this is a very large size plant, and you have to have a mix of the feedstock. That is very important. Alone one type of feedstock will not work here. Right. Next slide, please. This is second case. It is a smaller plant. As Mr. Guru Prasad said, that those subsidies were worked out on the basis of 12,000 cubic meter. But this plant is a small plant. It is having capacity of 7,500 cubic meter of biogas. And that makes it 3,000 CBG, compressed biogas per day. Now this plant feed stock is only pressed mud and cattle manure. No other agriculture waste is used in this plant. So the cost of the plant is definitely lower. It is just 19 crores. And I have shown an output of fertilizer also. The admissible subsidy to this size of the plant will be around 2.5 crores. So the effective cost of the plant will be less by 2.5 crores. Then the sale rate, which actually the sale rate is always negotiable with the buyer of the CBG. So here it is 63 per ton. In this case, 63,000. And then dry fertilizer and liquid fertilizer can also be sold. The normal payback period to CBG plants is in the range of 5 years to 6 years. So in this case, it is 5.16 year. And IRR will be of the range of 14%. Next, please. This is a schematic showing the use of bio-CNG. That is the raw material collection, organic waste, cow dung, energy crops. One energy crop is also being used around India, that is the Napier grass. That is being used for this biogas production, and it is being promoted also. And this is the purification system and compressor, and it goes to the car and for household lighting, and the slurry is fed to the sent to the farm. Next. This is the typical photograph of a compressed biogas plant, large size. And this is a first photograph is a gas engine, and second is a complete biogas plant again. This is the scrubbing unit, uh, which is basically water type. That scrubbing unit was of water scrubbing unit. Next. Now, this is the second part. One thing which I would like to tell about the biogas plants, that the oil corporations, oil majors like Indian Oil, HPCL, BPCL, they have launched a program of Satat. That is, that program, it promotes the compressed biogas plant installations and a guaranteed buying from the generator, biogas generator, to their rather CNG filling stations. And they have fixed that 46 rupees plus taxes as the prices. But I have seen in one document that they can negotiate at a higher cost also. That depends on the location of the plant. They are giving some transportation subsidy if the plant is at a distance from their this CNG station. So this Satat program, and they also promote whatever the manure, biomanure is available from the plant, the sale of the biomanure. And uh, one more point which I missed in my slides is that whosoever uh, sets up this CBG plant, he gets an income tax exemption also for the 5 years under Section 80 JJA. And that is, you can always get, and in some states, they are giving further incentives that they will provide land at a very nominal lease rent, and the machinery which is required for baling and raker, those things, government of India is already providing some subsidy, heavy subsidy, 50% subsidy for the machines, but some states are providing 30% additional to that. And electricity duty is exempted. Those are the incentives the government of India and the state governments are providing for setting up the biogas plants. So it is definitely a very lucrative option, and the payback period with these subsidies added will be definitely less than the period which I mentioned, 5 to 6 years. Now, this is the second part, biomass, use of biomass for power generation. This I have mentioned because in the new policy, a gasification is mentioned, and a particular subsidy has been given for the gasifiers, setting up of gasifiers and for power generation. Briquetting is an additional part because MNRE gives the subsidy on briquetting also. It is 9 lakh rupees per ton of the briquetting plant capacity. So the agriculture wastes normally have the low calorific values. And they cannot be, when they burn, they have to be burned for higher quantities. So in briquetting, the agriculture waste is densified. and it's converted into fuel pellets and briquettes. And they are used for power generation. NTPC has come up with a scheme to buy a minimum quantity, guaranteed quantity for their power plants all over the country. So, setting up of a briquette unit is also a good position here.
Yes, so
Next.
this is an added advantage also. If anybody is very close to an existing NTPC power plant, then making briquettes and supplying to them also is an added advantage. Thank you for bringing this out, Mr. Ravi.
Next slide, please. These are the processes used for briquette making. One is a press. It is a simple mechanical or hydraulic press which converts the agriculture waste into the briquettes, which is for the small plants. Second is screw extruder. It extrudes the briquettes, and there is an arrangement of heating also in this, so that the lignin present in the agriculture waste comes out and it acts as a binding material. And heating also reduces the friction. These extruded briquettes, they have a very good shape and appearance. Next. Third one is the pellet presses. In these high pressure briquettes are formed through dies. Dies are, I mean to say that roller passes over the dies, and it is agriculture waste is pressed at a high pressure. And when we go for a large scale commercial briquetting plant, then this process is used. Next. These are the briquettes. Next. This is an screw extruder and this is a press. These are the two different technologies here. This is the flow chart of this agriculture waste, then it is crushed in a fine powder. Then moisture is removed from the waste dryer, and then through a briquetting machine, it is sent to the packing. Meanwhile, if charcoal type is required, then it passes through a charcoal furnace. That gives a high calorific value to the briquettes, actually. That is why I have shown here charcoal bar furnace. This is the raw material. Oh yeah, next. And this is the sizing. This is the press machine, extruder, and this is the fuel pellets. Next. This is the general sequence of the process for briquetting, which I have explained by that figure. Next. These are the properties of the briquettes. Basically, they are used because they have high energy. Their fixed carbon content is much higher, and the calorific value is also higher than the loose agriculture waste. And second thing is that they are clean, no smoking, carbon residual is very low, and they have good shapes so that they can be used very conveniently at any boiler or any site. Right. Next. This is the project detail of a briquetting plant, 30 tons, 50 tons, and 100 tons, which I have shown the basic cost. Project cost is 75 lakhs, 1 crore and 2.5 crores. The important thing is the raw material availability. 9,000 tons, 15,000 tons, and 30,000 tons are required. But when land is much not uh, high, the requirement of land is not high in this case. Next. And this is the operational summary. I'm showing this because the investment payback period
Sir, we
is
have to hurry up a little bit.
but I'm just finishing in 5 minutes.
Sure.
One, it is of the range of 1.23, 1.26. That is important. Otherwise, that means that the payback period is good for the briquetting and there is an assured market from NTPC. Next. This is about the gasifiers. The gasifiers, the agriculture waste is burnt with the low oxygen presence. That is, it is partially combustion, and it produces the producer gas, which is a carbon neutral gas, because the same thing which applies to the compressed biogas plants, same thing applies here also with the agriculture waste, that whatever the carbon we have taken from the atmosphere, we are giving back to the atmosphere. And this producer gas is normally used in dual fuel engines or 100% gas engines. Direct applications are also there. Next. This is the composition of producer gas. It is mainly consisting of carbon monoxide and hydrogen. Methane is present in very low volumes. Next. This is the process of rather converting the biomass into the producer gas. One is the updraft. Updraft means air is fed from the bottom and the biomass is fed from the top. Downdraft is air and biomass both are fed from the top. And the third one is downdraft throat type, in which the air is fed in the middle and biomass is fed from the top. And then these are the different stages, like drying of the biomass, then it goes for the pyrolysis, then it is combusted, and finally the reduction where the gas is formed. Next. This is the same thing. These are the reactions which take place in that area. Yes, next. This is the cost of the gasifier. A 100 kilowatt gasifier will cost somewhere around the order of 22 lakhs, and subsidy is 2,50,000. Net project cost is 19 lakhs 95,000. And these are the operational parameters. And it is assumed that 70% of diesel is replaced in a dual fuel engine. Next. Then this is the cost of the raw material, rice husk, cost of the 30% diesel, as 70% has been replaced by the producer gas. So what is the cost of the 30%? And then other expenses. And if this system would have run only on diesel, then what is the cost? That is 97 lakh 20,000. So the net benefit, if we use a gasifier to the consumer, is 24 lakhs 52,000 in a year. and which shows the payback period is less than a year. So gasifier is one of the very good system using agriculture waste and getting the fuel from it. Next, this is a schematic showing the gasification and its use. Next. Right, thank you.
Yeah, thank you, Mr. Arvind, for I would say, kind of a session which is being given in a very short duration. Of course, it requires much more detailed and in-depth analysis. But thank you for briefing it up in short duration. We will obviously have a lot of questions, and I will take it up as and when it comes. Next, I would like to invite Ms. Mehta to throw some light on the new policy or the change in the existing policy that has come out, and what are the subsidies that the entrepreneurs can look at. Over to you, Ms. Mehta.
Just a minute. Yeah, I'll start sharing the presentation.
Yeah, sure.
Yeah, I hope the slides are visible. Hello?
Yes, you can click on full screen view.
Yeah.
Okay, sure. Yes. So, good afternoon, everyone. In the previous session, Arvind sir had given a good insights on how a biogas plant is set up, how bio-CNG, biomass, briquetting, these plants are set up, what is the cost involved in, setting up these plants, as well as what kind of payback period, what kind of IRR an entrepreneur can expect from, these renewable energy projects. Now, I'll be focusing more on how to finance these projects. See, the traditional way of financing these projects is the entrepreneur's own contribution. And also nowadays, banks, financial institutions are willing to fund these kind of projects because government is putting much and more thrust on these renewable energy programs. And also, as a part of the promotion of these renewable energy sources, government is incentivizing these kind of projects by way of providing certain kind of subsidies, incentives, or grants. So in this session, we'll quickly go through what kind of subsidies and grants are available from the central government for setting up these plants. So let's start with the Waste to Energy program. Government has notified this program in the month of November. It falls under the National Bioenergy Program of Ministry of New and Renewable Energy. And this program is applicable for the next 5 or next 4 financial years, starting from financial year 2021 to 2026. There is an umbrella program of national bioenergy, and this umbrella scheme is implemented for a period of financial year 2021 to 26. And there is a budgeted outlay of around 858 crores under phase 1. Now, there are 3 sub-schemes of this national bioenergy program. The first sub-scheme is Waste to Energy program, which derives energy from urban waste, industrial waste, agriculture waste, or residues. And the budgeted outlay for this particular program is 600 crores. The second sub-scheme is Biomass program. It involves manufacturing of briquettes, like Arvind ji has given us fair understanding about how this kind of plants are set up. So briquettes, pellets, and promotion of biomass, non-bagassed waste, co-generation projects. This involves budgeted outlay of around 158 crores. And a third is a biogas program. It is nothing but a gas produced through biomethanation and anaerobic digestion of the organic matter, like we have seen in the previous session. And there is a budgeted outlay of 100 crores. So totaling around 858 crores of amount of budget is sanctioned for implementation of this national bioenergy program. So let's start with Waste to Energy program first. So this Waste to Energy program involves generation of energy from various urban waste, industrial waste, which is, say, for example, a food processing industry or say cold chain. They generate a lot of industrial waste like rotten potatoes, tomatoes, or grapes, or any other kind of fruits. So this kind of industrial waste, which is generated by way of food processing industries. Secondly, agricultural waste. A lot of as we have seen, the post-harvest losses in India are too high, around 20%. Okay, these are the post-harvest losses, means the losses which are involved in handling of various fruits and vegetables, because we don't have a lot of supply chain infrastructure. So there's a lot of agricultural waste and residues are generated. So we can generate energy from these kind of wastes.
Miss Megha, your slide is
Yes.
not changing. Have you?
Yes, I have changed it.
It doesn't show though. Maybe you can go on a slideshow.
Yes, I
In
am.
your, you
Yes.
on your this one, you can go to slideshow and then click on.
Now you can see.
Yeah, now the slides have changed, but it's not come on a full screen still. So if you go
No, I
on
think.
the top on slideshow,
Mhm.
slideshow, and then you can give from
Now,
current slide.
now is it visible?
No, it's still showing in this one. Maybe you can stop sharing and again share.
Okay, okay, we'll do that. I think in a full screen it has a problem.
Full screen only has a problem because when you shared, I think you shared only the window.
Okay,
So if you share all screens, then I think it will be better.
okay, let me try.
Because full screen goes on to a new window, no?
Ah, so now is it visible? But I think in a full screen it again has a problem.
Full screen it won't go because when you give the sharing option, like when you unshare and share, it asks you full screen or only the screen.
Only this screen.
No, you select all the screens.
Okay.
When
Or can you
you,
share the slides from your end?
yeah, we can share it.
Okay, okay, then I'll stop sharing from
Yeah,
here.
you can stop sharing.
Yeah. Okay, we have completed this. There's a budgeted outlay of 858 crores. Next slide, please. Right. So the objective of this waste to energy program is to support setting up of waste to energy projects for generation of biogas, bio-CNG, power, a producer or syngas from urban, industrial and agricultural waste or residues. And there is a certain central financial assistance available for setting up these projects. Central financial assistance is by way of a grant or subsidy, which is a non-refundable source of finance for any developer who wants to set up these kind of plants. However, this subsidy is available only after the successful commissioning of these projects. And the implementing agency for these projects, government has appointed IRDA, that is Indian Renewable Energy Development Agency Limited, as a monitoring body to govern these kind of projects. Yeah. Next, please. Now, what are eligible entities who can set up these kind of projects? It could be a company. It could be a consortium of companies, like 3 or 4 companies coming together, 3 or 4 small, medium scale industries coming together and setting up these kind of projects on a joint venture basis. Or a special purpose vehicle can be formed. That is a separate company having a specific objective of setting up biogas or bio-CNG or biomass projects or a waste to energy project. A company or a partner of the consortium can be a local body. It can be a municipal corporations. It can be a government or private sector companies or firms. Then even central public sector undertaking, that is PSUs, can also eligible to set up these projects. Joint sector companies, even trusts, NGOs, societies, cooperatives can also set up these projects. there are certain agri cooperatives or dairy cooperatives. When there is a lot of agriculture waste or dairy waste is getting generated, so those kind of cooperative societies can also are eligible for these kind of projects. Even the farmer producer companies are eligible to set up these projects. Then entrepreneurs, partnership firms, limited liability partnership firms, energy services companies. So all these entities are eligible as an applicant to avail subsidy under this program of waste to energy by MNRE. Next, please. Yeah. So funding pattern. In the previous session, Arvind sir has given us fair understanding about there are a lot of subsidies are available for these projects. So what are these subsidies available? So there are certain cost norms, suggested or standardized by the government. So this for calculation of these subsidies, these cost norms are applicable. So let's see what kind of cost norms are available and what kind of subsidies are available. So standard CF is nothing but central financial assistance, which is a grant or a subsidy, or it's a kind of a non-refundable incentive by the government. And this central financial assistance is in proportion with the installed capacity of the plant. So for the biogas plants, it's 0.25 crores or 25 lakhs per 12,000 cubic meter per day. And the maximum subsidy available for these projects is 5 crores. Then second is a bio-CNG, enriched biogas, compressed biogas projects. So for this, the financial assistance is available at the rate of 4 crores per 4,800 kg per day for bio-CNG generation from new plants. And for the existing plants, it is 3 crores per 4,800 kilograms per day if it is an existing biogas plant. And maximum financial assistance available for project in both the cases is 10 crores. So third one is biogas based power generation. So for these kind of projects, if it's a new biogas plant, then 75 lakhs per megawatt is available as a grant or subsidy. Then if it's existing biogas plant and suppose some kind of additional or expansion is carried out or some kind of new machinery has been installed in the project, then for the new machinery part only the subsidy or grant is available at the rate of 50 lakhs per megawatt. And the maximum assistance available for projects in both the cases is 5 crores. Next, please. Another number 4 is power based on bio and agro-industrial waste other than municipal solid waste through incineration process. So only if it's agriculture or agro-based industrial projects are there and the power generation from these kind of projects, then 40 lakhs per megawatt is available for these projects, and the maximum subsidy available is 5 crores per project. Then biomass gasifier for electricity or thermal application. It is rupees 2,500 per kilowatt. If it's a dual fuel engine for electrical application, we have seen in the previous slides, the biomass is generated from various types of machinery. So if it's a dual fuel engine, then 2,500 per kilowatt. And if it's a 100% gas engine for electrical application, if this kind of project is there, then rupees 15,000 per kilowatt. Rupees 2 lakhs per 300 kilowatt for thermal application. Okay, so for electrical application it is different. In case of dual fuel engine it is different, and for thermal application different kind of subsidies are available. So it depends on what kind of machinery, plant and machinery is used in the project, and depending on plant and machinery used in the project, it is the grant is applicable. So what is the funding pattern? In case of developer is setting up new bio-CNG or power plant based on biogas already available. Okay, if the biogas is already available or it is generated from an already operational biogas plant and that biogas plant has already availed financial assistance, then the financial assistance or the grant is available only for the conversion purpose. Say for example, if the biogas plant is already existing, it is already operational, or it has availed subsidy from previous schemes, then if the biogas to bio-CNG conversion, only for the conversion part, the grant is available. And that is rupees 3 crores per 4,800 kg per day. Or if it's a biogas to power, then it is 50 lakhs per megawatt. Next. Next, please. So what kind of projects are eligible under this? So first preference is given to all the greenfield projects. Okay, greenfield projects means the entire new equipment, new plant and machinery, everything is it's like a project starting from the scratch. So all the greenfield projects are given preference under this scheme. And the second type of projects will be the expansion projects. Like we have seen earlier, if the biogas is already available and you are just doing the conversion into bio-CNG or any other form of a gas, then for expansion projects, only for the expansion part, installation of new plant and machinery, the financial assistance is available under this program. Next, please. So there is a special financial assistance available in certain category of states. Say government is doing giving a lot of thrust on northeast states and as well as the hilly kind of states. So like northeast states like Arunachal Pradesh, Assam, Meghalaya, Nagaland, these kind of states, Sikkim. Then hilly states like Himachal Pradesh, Uttarakhand, Jammu and Kashmir, Ladakh, Andaman Nicobar, Lakshadweep Islands. Then eligible financial assistance is 20% higher than the standard financial assistance which we have seen above. Okay, so whatever is the standard financial assistance available, additionally 20% incentive are given to this category of states. Next, please. Then special financial assistance is also available for biomethanation plants set up under registered gaushalas or shelter. Okay, so if it's a cow shelter, gaushalas are there, then there is again a 20% higher incentives are given. So biogas, bio-CNG or biogas-based power generation plants, which are based on cattle dung. The main feedstock is a cattle dung. If these biogas plants are set up by gaushalas independently or in partnership with any other firm, then these kind of projects are also eligible to avail 20% higher incentive than the standard financial assistance available, which we have seen in above table. The only condition is that these gaushalas, just a minute. Please go to previous one. These gaushalas should be registered with the respective state government. Okay, so it's a registered as a registered entity with the state government. Then they can avail a 20% higher incentive. Yeah, next please. Now, what kind of projects are not eligible under this kind of scheme? Okay, although these projects can avail incentives under any other scheme of government, only for the waste to energy program to avail subsidy under waste to energy program, these projects are not applicable. So first is if the waste to energy is generated from waste heat, waste plastics, polymers, tires, then these kind of which is inorganic waste is ineligible for availing incentive under this scheme. Then biogas plants up to 250 kilowatt capacity for power generation and up to 2,500 cubic meters per day for biogas generation capacity are ineligible to avail incentive under this scheme because they are covered under biogas program. Okay, so suppose if any entrepreneur or any farmer or farmer cooperatives want to set up these biogas plants of this capacity, then they can go for a biogas program. There is a separate scheme available for these smaller biogas plants. Then municipal solid waste refused derived fuel to power projects based on certain thermal technologies like incineration, gasification, pyrolysis. Then these kind of technologies, if the power is generated by using these kind of technologies and if it's from the municipal solid waste, then these kind of projects are also not considered under this program. Okay, so only organic waste, agricultural waste, urban waste, industrial waste, agro-industrial based waste are eligible to avail grant under this program. So what is the procedure to avail these financial incentives? First is the government has set up a dedicated portal that's called a Biourja portal. We have, as an entrepreneur or as an applicant, you have to register under this portal. The registration also involves submission of certain documents like detailed project report, techno-economic feasibility report. Suppose you're availing a bank loan, then bank sanction letter. Then if the loan is availed in bank, appraisal note, then what kind of plant and machinery is involved in the project, the vendor quotations. So whatever the checklist is given in the scheme. So as per the checklist, the documents have to be submitted at the Biourja portal. Then there is a project approval committee which will go through the documentation. If there are certain drawbacks or there are certain queries, then they will raise the question to you. And then the project approval committee will give in principle approval to these projects upon satisfactory answer, satisfactory clarification of any doubts raised or any queries raised. Then after in principle approval, the next step is we have to start constructing the plant, appoint plant and machinery vendors and commission the plant within 24 months for waste to energy. And in case of biomass gasifier, the plants has to be commissioned within 12 months from in principle approval date. So from in principle approval date, the time starts. 24 months is the eligible time available for commissioning of waste to energy, and for biomass gasifier, it's 12 months. Now, once the plant is commissioned, you have to invite an inspection agency. There are certain 3-4 inspection agencies are empaneled with MNRE. So out of these 3-4 agencies, we have to choose one, and you have to invite them for the plant performance testing. So they will visit the plant and they will assess the plant load factor. So based on the average plant load factor achieved during minimum 3 consecutive months, the financial assistance will be released. Suppose the plant load factor is more than 70-80%, then 100% grant will be released. So depending on plant load factor, the plant load factor will determine how much financial assistance is available. So plant load factor is nothing but a ratio of average electricity or energy generated by the plant to the maximum energy or electricity that could have been generated in a given time. Okay, so these inspecting agencies will assess the plant load factor and they will give the inspection report. Yeah, next please. Okay, so upon inspection report, we have to submit the first stage document is nothing but in principle approval documentation. After that, you have constructed the plant, you have set up the plant, you have commissioned the plant. The inspecting agency has given their report. Then, along with that report and certain other documentation as given in the checklist, we have to again submit to the BioUrja portal. Okay, and then after submission of this, like these are the documents like environmental approval, consent to establish, and if there is a bank loan involved, then the closure of loan closure report or the bank whatever banking compliances are there. So those kind of compliances and also the CA certificate from CA regarding the project cost. So all these documentation again we have to submit at the BioUrja portal, and then upon successful assessment of these kind of documents, the subsidy or the grant will be released. Okay, so this disbursement is happen only after commissioning of the plant. During the construction phase, the grant is not available. Now, however, advanced disbursement happens during construction phase in case of certain projects. Okay, there is one exception, that is bio-CNG plants. Those bio-CNG plants who have signed bio-CNG, that is compressed biogas purchase agreement with government oil marketing companies, like Arvind sir has mentioned previously, it's just the program by certain oil marketing companies like BPCL, HPCL, IOCL. So suppose there is a purchase agreement signed with these kind of oil marketing companies, and also the project or the entrepreneur has availed 50% of the project loan from any bank or financial institution, then in that case, the advanced disbursement of the grant is available in the construction phase. So in these kind of projects, the entrepreneur can obtain financial assistance during construction phase. Only in bio-CNG plants which are in purchase agreement with the OMCs. However, in other projects, excluding this project, the other projects, the disbursement will happen only after the successful commissioning of the plant. Yeah. Next, please. Okay, now this was about the waste to energy program. Now the second program is a biomass program. So biomass program, the objective of this particular scheme or the program is setting up biomass briquettes or pellets manufacturing plant and to support biomass non-gas based cogeneration projects. So earlier in waste to energy, we had a gasification process. So here it is a cogeneration process. So what kind of projects are eligible under this biomass program? So like briquettes or pellets manufacturing plant having minimum capacity of 1 metric ton per hour is eligible to avail grant under this program. And the subsidy or the grant is available at a rate of 9 lakhs per metric ton per hour manufacturing capacity, and the maximum assistance available is 45 lakhs per plant. In case of biomass, which is a non-biogas based cogeneration project, the minimum plant size required is 0.5 megawatt, and the central financial assistance available is rupees 40 lakhs per megawatt, and the assistance available is maximum 5 crores per projects. Okay, so next please. Now biomass has to be produced from crop residues such as paddy straw, wheat straw, mustard stalks, cotton stalks, wood produced through energy plantation, weeds, palm leaves, coconut shells, husk, wood waste produced from industrial operations like sawdust, offcuts, barks, etc. Agro-based industrial residues such as rice husk, barley husk, etc. Forest residues such as pine needles, branches, or stem of trees, etc. So the biomass which is produced from these kind of residues only applicable for availing central financial assistance under this scheme. Yeah, next please. So the procedure to avail this assistance is again the similar one. However, only the commissioning, there is a certain minor change of commissioning of the project. The procedure remains the same. The documentation may vary depending on what kind of technology you are using and what kind of plant and machinery is using. So submission of the proposal through BioUrja portal, depending on like what kind of checklist is given in the scheme. So one can follow the checklist, the documentation part, and submit these documents online. Then the project approval committee set up by the ministry will go through the documents, and if the documents are satisfactory, then in principle approval is accorded to them. In case of bank loans, the bank appraisal report or TEV report, techno-economic feasibility report, will suffice, and the PAC or the project approval committee will accord in principle approval. Then one has to start working on the plant. He has to set up the plant and install plant and machinery and start commissioning of the plant. So from the in principle approval date, if it's a biomass cogen project, then it has to get commissioned within 24 months. And if it's a pallets or briquettes manufacturing process, then the time period is 12 months. The commissioning period is 12 months from the in principle approval date. Then again, once the plant gets commissioned, we have to invite in the inspection team, or there are certain companies or certain institutions which are empaneled with MNRE. So we have to choose one of these inspection agency, and they will send a team and assess the plant loading factor, as mentioned in case of waste to energy program also. So the plant loading factor they will assess during minimum 3 consecutive months. Based on that, they will prepare the inspection report and submit it to the government. And based on the plant loading factor, how much plant loading factor is achieved. So based on that, the grant or the financial assistance is released. Plant loading factor we have seen in the previous program also. Yeah, next please. Okay, so this was all about to avail the financial assistance through biomass and waste to energy program, and government is promoting these programs in a big way, and now carbon credits and many other renewable energy programs are coming up, and there is around 858 crores have been already budgeted by the government for these 3 programs, and so entrepreneurs or farmers or farmer societies have lot of scope available. This can act as this can reduce your electricity bill, and also act as it can also generate revenue for farmers or as well as small to medium entrepreneurs. Yeah, so thank you so much.
Thank you. Thank you for a wonderful session. Again, very brief and crisp. Obviously, when you get into individual, aspects, there could be, different schemes that apply to a few people, and it might not apply to a few instances, which has to be studied on a case-to-case basis. Thank you, Medhaji. Since you are already here, one of the questions what has come up is the CFA can be availed before the commissioning of the project, or is it after commissioning?
Only for the bio-CNG plants, which has signed a purchase agreement with the oil marketing companies and avail 50% loan. Only those projects can avail assistance during the construction phase. Rest of the financial assistance, rest of the projects, it will be only after the commissioning. And that is also based on plant load factor.
Correct. Thank you. I think we will hold on to some of the questions that are coming up. Meanwhile, the participants will be seeing a poll on your screen. Maybe you can answer the questions which are coming up. About 3 to 4 questions will be coming up on your screen. Kindly answer it. And as you are answering, I think there are a lot of questions that have come up. I would, want to ask Mr. Arvindji. Arvindji, would you be knowing what is the current market price for the briquettes?
For the briquettes,
Yeah.
No, I don't have any idea. The NTPC has definitely fixed the price, but and they are providing some transportation assistance also. But the exact price what they have fixed, that I don't have any figure.
Right. Fair enough. I think we can, look at it and find out. A continuation of that question. See, a lot of entrepreneurs come to us, with an intention that they want to get into bio-CNG or biogas, or like you also mentioned, the briquettes that can be taken up. But for a new entrepreneur who does not have, much knowledge in this sector, what are the key, areas that you would ask him to start initially and then later expand into the other products? Because you have so much of experience in this sector.
See, it depends on the what type of raw material he is having in his area. First point is that without considering that, he just should not go ahead. And availability and the uh, tendency of the farmers, because the farmers normally prefer to sell it directly somewhere to the brick kiln owners. That is the most likely place where the agriculture waste goes. Press muds are definitely available, and so that if anyone thinks he should be some near somewhere a sugar mill, and some cattle dung should be available with him, and then he can go for a compressed biogas plant of a smaller capacity. Later on, he can scale up. So that is what I think he should um, go
Right. And
for.
typically these plants can be set up with a an investment of about 1.5 to 2 crores, is it?
No. For compressed biogas plants, in my slides under case 2, that is a small biogas plant of 7,500 cubic meters and 3,000 kg CNG. Slightly lesser plant than that can be set up, and but the uh, cost will not be less than 10 to 15 crores, because actually the secondary steps means after the production of biogas, that is the cleaning of the biogas is expensive. So the plant, yes, he can go for briquetting. Briquetting plants are cheaper, and with land, I think less than 5 crores will be required for a adequate capacity of a briquetting plant. Gasifier, if he requires uh, energy for his own use, because producer gas cannot be sold. So if he requires energy for his own use, then he can use a gasifier, considering the agriculture waste available in his area.
Can cornstarch straw be used as one of the raw materials if there is no sugarcane or paddy straw?
Sugarcane tops are normally used, because bagasse is normally nowadays not available. Uh, Mainly paper mills are using bagasse for paper production, or it is consumed by the sugar mills for co-generation activities in their own mill. The surplus is only available which is going to the paper mills. The sugarcane tops, they are available as agriculture waste and can be used for biogas production.
Right. And the bio-CNG buyback, which is there from the OMCs, so that has a similar price across India, right?
Yes, till to date.
Irrespective of what the
They
raw
are
material.
providing transportation cost if it is beyond, I think, 70 kilometers. If the biogas plant is beyond 70 kilometers from their CNG station, then they provide some incentive for the transportation.
Right.
And that is a very useful program. Means Satak program that is launched by these. Uh, they have a fixed commitment of 5,000 compressed biogas plants in the country. So, and not many have come up till to date.
Right.
I think the figure is
Uh,
60, around 60 biogas plants.
Correct. And also, this involves uh, biocoal also, or that is not included, is it?
Biocoal, some states are giving subsidies for biocoal plants also, additional subsidies. Like I know in UP, they have decided that each taluka will have one uh, biofuel plant, whether it is biodiesel, bioethanol, biocoal, or bio-CNG. And then they are looking for that a lease rent of 1 rupee per acre is available for the entrepreneur, electricity duty exemption is available, stamp duty for the land is zero. So these incentives are given by UP government. I do not know about the other states,
Right.
but biocoal comes under that.
Okay. And I think during the presentation, you also mentioned that press mud being one of the raw materials, and it has to be coming from the sugarcane plants. So, is this something which is definitely required, or there are alternatives to this?
The pressmate is a good option for biogas production. Pressmate goes actually from the sugarcane mills as a fertilizer to the farmers. Farmers buy the pressmate. But instead of that, it can go for a biogas production. That is a good, and the waste uh, balance is available, goes as a manure again to the farmer. So sugar, if a sugar mill is available nearby, then it will be a good option. And I think in UP and in Maharashtra, the pressmate is sufficiently available.
Correct. What is the water requirement, and is there this one to treat the wastewater again? Is there a requirement to treat the wastewater?
Normally, the wastewater which is obtained from the digester is separated from the solid portion and it is treated and recycled for the pre-treatment. So the requirement becomes less, but definitely you will require, depending on the plant capacity, some water.
Okay, but it is not a heavy water, requirement kind of a unit,
No.
right?
And considering the pollution angle of the water, the wastewater is recycled.
Right.
Or it, if not used for the pre-treatment, it can go as a fertilizer to the farmer,
Right.
liquid fertilizer.
Correct. One question to you, Ms. Mehta. I think you have previously also worked with agro producer communities, or the one of the participants in this program. You said could be communities of farmers. So, how does one go about doing it?
So, kind of farmer producer companies or dairy cooperatives, they usually have around 300 plus members, in that, and there is a lot of agriculture waste, dairy waste, manures, okay, organic manures especially. So all these can get collected, and as a community, they can take up these kind of projects, and they can also hire some kind of technical consultant who can advise them on raw material, on the plant and machinery, and they can go for prepare a detailed project report and submit it to on the BioUrja portal to avail these kind of subsidies or grants. There are communities in Gujarat, like the one which produces Amul milk. So all these large dairy cooperatives are already working on this. Like NDDB also provides, National Dairy Development Board also provides some kind of additional incentives. Also, various state governments are promoting this, and they provide other incentives like electricity duty exemption or water power exemptions, etc. So various other fiscal incentives are also available to them. So by combining these kind of incentives, the payback period would also be a little, they can reduce this kind of payback period.
Right.
So,
And
yeah.
also, like how Medaji said, and Mr. Arvind also mentioned a few minutes back. See, what will typically happen in these cases where we are using agro, residues or agro waste? is obviously when such plants become more in demand, and more plants are set up, and also ethanol is going to being one of the bigger plants that will be coming up. Lot of these
Right.
agro waste, what is there today, whatever prices are there, will eventually go up. So the best way to insinuate you from the price increases is making these companies as agro producer companies or farmer producer companies, where the farmers are also part of this company. So in that case, the prices will not, shoot up, tremendously. Obviously, there will be, inflation and things like that, and prices will go up of the raw materials. And although today's, bio CNG buyback price is fixed at 46, we can't take it for sure that it is written in stone that even 5 years down the line, government is not going to increase. Obviously, government will be under pressure, and the buyback prices will increase. We also saw during the presentations, there are a host of the byproducts that you can also look at, which you can sell it in the open market at open market prices. So, the overall feasibility of the project is not, 1+1=2 kind of a scenario. It has to be looked at based on your proximity to the raw materials, proximity to the stations where the bio-CNG is being bought, and finally at the kind of equations that are being made out with the raw material suppliers, as well as with the participants in this entire program. So I would suggest, you should not be too much concerned about the prices of the raw materials as of today, because as we mentioned, it is definitely going to go up. And the way to insinuate yourself from that is making these farmer producer companies or APCs, so that the farmer is also part of the overall program. I think we have overshot the time also for this webinar. I would like to thank our two stellar speakers, Mr. Arvind ji and Ms. Medha, for sharing their time and taking time off on Friday to share their knowledge. Of course, 1.5 hours is definitely not enough to give a complete picture on bio CNG and biogas. But this is kind of an eye opener to the new program that the change in the program that the government has done, and what additional things have been added other than the Satat program that was initially floated. So each state has given some more subsidies or some more benefits to the promoters, so which can be looked at on a state to state basis. I would like to thank all the listeners and the participants, and also invite all of them for the next session, which starts at 3 o'clock, where we'll be talking about ethanol and the benefits, and also what are the government policies that are there for setting up the ethanol projects. Thank you once again for the participants as well as the speakers. Has been a splendid session, and we hope all of you will join for the second session. Thank you, sir. Thank you, Medaman.
Guru. Thank you. Thank you, Arvind sir. Thank you so
Thank
much.
you.
Thank you, Meera. Thank you.
Thank you.
The recording has been